I'll just turn it on for a second. So this is going to be a workshop, right? There's going to be hands-on labs, and we will provide you the infrastructure to do that. And all you need is a web browser. So we'll give you access to a full lab machine through the web browser. I'll explain how to connect to that machine in a second. And then you should be able to follow along with the lab material on that machine, on that web-based VNC machine that we give you access to. So let's give it another minute or so. I see a handful of folks are in, and a few more are joining. So let's just give it another minute or so. Okay, I think we are going to get started here. We have a few folks, and if more join, then we'll just admit them. But let's, like right now. All right. So let's get started. So let's set a little context. We're gonna get started here. What you can expect is a deep dive into Istio multi-cluster and Gloo mesh for managing Istio across multiple clusters using hands-on labs. You can expect maybe the first 20 minutes or so of sort of a level setting, kind of explaining a little bit about the problem area that we're going to be exploring today. And then we are going to assign lab machines to each of you. Please feel free, this is a Zoom, so you can unmute yourself, you can ask questions, or you can ask questions in the chat. There should be, let's see if we look on here. Yeah, so we should, let me get to open the chat up on my machine. There we go. You should just see a message pop up. I misspelled it accidentally, but so we're happy to have you join us. Ask questions, please. We're going to go over some of this stuff is when we talk about multi-cluster, things can get complex, but hopefully we've crafted the lab material step by step and the environment itself to enable you to dig in and explore and learn without too much trouble here. So let's get going. First of all, thanks for joining in. My name is Christian Posta. I'm the field CTO here at Solo, and I've been involved in helping organizations build out large-scale distributed systems for quite some time now. Been contributing to open source for a long time. Been involved with the Istio and Envoy communities for the last 4 years, actually, even before Istio was announced generally available. I wrote the first book on Istio called Introducing Istio for Microservices, and I'm in the process, hopefully nearing completion, of writing Istio in Action. I've been working on this like 2.5, almost 3 years now. It's about time to wrap it up. I work here at Solo and came over here to work at Solo specifically to help organizations be successful in adopting service mesh technology, as I believe that is the right way to architect for these types of problems, which we will talk about. Feel free to reach out to me on any of the mediums that I've linked to here. And I'm joined with Adam Saya from my team, who is going to also help today. Adam?
Yeah, hi everyone, thanks for joining. So as Christian said, I will help with the labs later. I'm field engineer here, working with Christian in the field, helping people, customers adopting service mesh and gateways.
Awesome. Okay, let's get going. And so what we do at Solo and the problem areas that we're focused on is you're starting to modernize, you're starting to maybe deploy into containers, Kubernetes, these types of things, building CI/CD around it, and maybe some of your observability systems and so forth. You're building your infrastructure to be able to support your teams to go faster. Right? That's the ultimate goal with the platform you're using or building. And the area that we are focused on at Solo is once you've deployed your apps, how do they communicate with each other? It sounds easy on the surface, but for those of you with experience building these systems, anything that has to talk over the network, you know that the devil is in the details, that it gets complicated quickly, especially when your architecture presupposes breaking things up into small little pieces and talking over the network more and more and more, especially in a cloud environment where these networks are, we know the network's unreliable, even more unreliable, unpredictable. So what we focus on is building the pieces that allow your applications to connect to each other, load balance, find each other, and do that in a highly decentralized way, but maintain things like security, things like understanding, observability, understanding what's happening in this large distributed system. Now, in the past, we would see that implemented as enterprise service buses or API management. Everything would be forced to talk through this centralized thing, which from a technology standpoint doesn't work very well in a cloud-like environment. From an organization and process standpoint, teams would build these highly centralized governance bodies and ticketing systems around that and so on. And it would not be very conducive to a decentralized microservices style model, right? So at Solo, what we're focused on is building the technology to better fit solving those problems in a decentralized way. We will take a look at Gloo Mesh today, which is a piece of this puzzle. Gloo Edge, our proxy, Edge Gateway proxy, developer portal, and so on layered on top of that. Right, and so at its core, Envoy is the secret sauce. Just like Kubernetes became the secret sauce for building these container orchestrators and platforms built on containers, Envoy is that magic piece, you could say that kernel, that applies to building application networking centric frameworks like service meshes or gateways or federated gateways, decentralized gateways, right? And so that's the type of architecture that we're going to be looking at and exploring today. But bringing the bigger pieces together, running something like this, where your traffic is secure from end to end, where you're able to make your observability systems more powerful and more interesting because you're collecting network telemetry about what's happening between these systems. You're able to apply policy across these systems about which services are allowed to talk with which others, which ones are exposed, which ones are not. And the ability to run this successfully and cohesively through a single pane of glass. That's what we're going to be looking at and exploring today. Now, a piece that I think we ended up moving to a different lab is sort of now once you have this decentralized infrastructure, how do you still make cohesive sense of it from a API developer perspective? How do you go find these services that might be running across many different clusters and clouds? How do you sign up for them? How do you document them? How do you share them with the rest of your organization or outside of, that is still part of the equation here. Just the underlying pieces are not as centralized. So that's what we're focused on at Solo. If any of this stuff, Envoy, Service Mesh, WebAssembly, GraphQL, any of these things interest you, then please come talk to us. We would love to. We're growing, we're hiring as quickly as we can, and we'd love to grow the team here. Last bit is we are putting out our own conference dedicated to this topic toward the end of this month. So we already have the agenda up, and then some of the speakers are listed there. So go ahead and take a look at that. Now, the assumption coming into this is that this is not an intro to Service Mesh workshop. We do have a sort of a more Istio focused hands-on workshop, and I can give you details about that later. But this is the next couple of slides will level set a little bit, but this is not necessarily an intro level workshop. So understanding and being familiar with some of the concepts that a service mesh might bring, some of the problems a service mesh might solve, are things around application to application service discovery, client-side load balancing, security and encrypting the traffic between services, controlling the traffic and in different ways, maybe by percentage or by content or by region and so on. And then the last part in this list is that the service mesh provides an API for programmatic control over the network. Now, like I said, in the past, what we would see is route everything through the ESB, route everything through the API management, and you would use whatever capabilities or knobs or levers that are exposed by those pieces of technology. But as things, the important part about cloud is getting access to and controlling infrastructure through APIs. And this is no different in the service mesh solution. And so being able to in this case, declaratively manipulate the behavior of the network at runtime is extremely powerful. Right, and so just again to recap, in the service mesh deployment, service mesh architecture, we are deploying these smart little agents or proxies along with each application. So they effectively become part of the application. They happen to run out of process of the application, but they're atomically treated as part of the application instance. So you have a JVM, then you run one of these little proxies next to that JVM, or you have a Node.js process, same thing, right? Tightly atomically bound to that instance. And then when that instance tries to talk to the network, it goes through this proxy. And when applications try to talk to it, it goes through this proxy. Conceptually, it's just an interceptor, right? If you've been building services in the past and using frameworks where you can inject behavior into the pipeline that goes over the network, it's exactly the same concept. It just happens to run out of process and is driven by configuration. Also makes your applications easier to write and understand because you're not co-locating all of this additional networking logic in there. Istio is one of those service meshes, probably the most dominantly deployed in production service mesh today. I don't know if you had a chance to see some of the content at IstioCon. I was on the organization committee, and I can tell you we had so many really, really good talks submitted to that conference. We could only pick a handful, but it's just a snippet of what's actually happening as people adopt it in real production environments, and it becomes a foundational piece to their operating platform. Now, taking and running Istio in a single cluster, a single environment has some challenges, just like running any new piece of technology has some challenges. One of the things that we'll start to look at is its API. Istio's API was built almost just barely a little abstraction above Envoy Proxy's API. Envoy Proxy its configuration metadata and the API service that it has is incredibly, there's a lot of knobs and switches in Envoy. It's extremely powerful and extremely verbose. Istio tries to tone it down a little bit, but it's still pretty low level. And what you see as people start to adopt the functionality in a service mesh, like the resilience pieces, timeouts, retries, circuit breaking, deadlines, like the chaos injection type stuff, injecting faults, traffic routing, traffic splitting, security, these types of, you see different parts of the organization or different parts in your system, different people, different roles that care about those specific pieces of functionality. Maybe the team deploying their application cares about how traffic gets matched coming in and gets routed to their app. Maybe a service team deploying and calling another service cares about the timeouts and circuit breaking settings that are applied when calling that other service. Maybe the SRE team cares about setting up things like cores or setting up things like traffic shifting when you're deploying a new version or fault injection. Maybe the platform team cares about scoping down configurations and applying security policies consistently without breaking existing apps. So these different roles in the organization that might be part of your system care about different pieces of what a service mesh can offer. And what we'll see is that the service mesh, Istio in this case, has an API for doing this, but it's fairly low level. So when different parts all want to operate on the same piece of functionality, there's contention, right? And what we've seen people do is who've successfully gotten past this is they've written their own custom abstraction and layers and APIs on top of Istio. And when we look at it from an Istio community perspective, when we look at it, we say, yeah, that was the intention. Another thing is when you're running Istio beyond one cluster, maybe across multiple clusters, the configurations that it takes to make this successful, things like adding service entries to enable service discovery, things like adding the right virtual services on the right clusters. Because we know that if the account service in cluster 1 needs to talk to the user service, that there might be instances of the user service on cluster 1 as well as across multiple clusters. And so the configuration needs to be set such that service discovery, load balancing, connectivity, trust, mutual TLS, all of these things can be successfully accomplished across multiple clusters. Now, Istio has the nuts and bolts and hammers and screwdrivers to be able to do that. Something needs to put that together, right? So, looking at this a little bit more, expanded a little bit more, shuffling around all of these different configs, each with their own semantic meaning. So how the account service routes to the user service in cluster 1 is different than, let's say, the account service routing to the user service in cluster 3. So there's some inherent directionality there. And so in general, once you start to deploy a service mesh, either an individual cluster or across multiple clusters, the mesh is an important piece of the puzzle, but actually operating this in a day 2 style across multiple clusters, getting consistent security, taking advantage of the capabilities of the mesh becomes, it doesn't come from some, you have to build those pieces, that automation to do that. And that's exactly what we're focused on with our Gloo Mesh open source project and enterprise supported offering around it. So Gloo Mesh is that automation layer. And the automation layer is there to focus on a few main things. One, to simplify your life as an operator of Istio so that you can successfully use the capabilities and features around it. To operate Istio across multiple clusters on-prem or in a public cloud or both, and shield you away from the, having to know exactly where every service is deployed. Another piece of this, as you can see, is Istio is what we're focused on, because it's what most people are deploying into production today. But this abstraction is in place, and this automation is in place, knowing that you might include other meshes. Maybe you go to Azure, and in a year's time, maybe the Azure Service Mesh, which is will be based on OSM, is production ready and good to go, and you want teams to use that, so you want to be able to pull some of those workloads into your overall network, overall mesh. Or maybe you go to AWS and use that mesh. So Gloo Mesh right now is focused on Istio, knowing that you might end up in situations where you need to extend out to additional mesh implementations, and we're there to cover that for you as well. So Gloo Mesh, the product, is our distribution of Istio. So it is a service mesh, and it's a distribution of upstream Istio with enterprise support, SLAs, CVE, and backporting for long-term support for a year per release. The community only does 6 months. And we also put it through additional validation testing and so on, based on use cases that we experience with our customers. And then we have some of the largest customers that have deployed Istio in the world. And then along with that comes the management and automation plane that simplifies adopting Istio, which we're going to take a look at in depth today. It solves things like the role-based access, what personas in the organization need to drive the features, and how does that get compiled down into Istio config. Things like security, so unifying and controlling trust domains across different clusters so that workloads can trust each other and communicate with each other. Taking care of all of the Istio configuration, automation, service discovery, all those things, and then building higher level capabilities on top of that. So this idea of a global service. When service A talks to service B, does service A really care where service B is deployed? It would like to use things like locality and route to a service B that's closer to service A, but if it needs to route around failures or route to different availability zones because other services are overloaded and so on, like all of that stuff should happen. The network should take care of that, and the applications should just focus on communicating with each other. Okay, so just to be a little bit more to the point, Gloo Mesh is focused on reducing configuration toil, giving you the peace of mind around running Istio, both from a enterprise support standpoint, but as well as let's simplify this and actually get this to work nicely in our organization. If you happen to introduce other service meshes in the future, the API that we built is not tied specifically to any one mesh. We can extend that to other ones. At Solo, this is what we breathe day in and day out, working with customers deploying Envoy-based technology, Envoy gateways, Envoy service meshes in production, and so getting to work with our team. So this is an important part of bringing a mesh into your environment and being successful with it. All right. So let's skip some of this stuff. Ultimately, this is what the Gloo Mesh deployment looks like, right? So you start off with Istio, right? You have production support around that, some specialty builds for those running in government environments, government workloads around FIPS. So we have all that. But then once you start to deploy that across multiple clusters, the management plane piece for automating and keeping this architecture up and running successfully. Right, and we're going to take a closer look at the APIs that we will use top of the management plane that can both be segmented per role or persona user of the mesh capabilities, as well as a more simplified view of what it's like to configure traffic and security access policy and that kind of thing. All right, so let's jump into the labs. On the lab, and I'll explain how to get access to the lab machines in 1 second. But the lab architecture, what you're going to be looking at today, is based on something like this. You have multiple clusters of Kubernetes. We'll deploy Istio into those clusters, and then we'll have a separate cluster for the management plane. And we're going to run this all on Kind, Kubernetes, and Docker, where we'll have 3 different clusters, 1 for the management plane, 2 for the Istio service meshes. We're going to run this on VMs that you will have access to, and I will give you the access instructions right now. So I have a spreadsheet here. I'm going to paste this in the chat. Let's paste it to everyone. VM allocation spreadsheet. And you all should be able to click on this. Yeah, all right, I see people popping in, so that's good. The permissions are good. And what I want you to do is put your name, your first name, last name, next to a particular IP address without conflicting as much as possible. And then I'll tell you exactly what to do with that IP address. So let's take a second for folks to, it looks like we have 28 minus 25. So we should have enough VMs listed here. I have 27 VMs listed here. There are, looks like 25, 24 folks. So go ahead and allocate yourself a virtual machine. And then once you have that allocation, once you have that allocation, then I want you to fire up your favorite browser. Fire up favorite browser. Oh, here, let me not cover up some of this stuff. Hopefully you all can see my screen okay. Fire up your favorite browser, go to that IP address, followed by / followed by guacamole. So you should see some of those instructions here as well. And then once you get to that screen, similar to this, if anybody's having issues, then either unmute and ask or jump into the chat and we'll try to help. But yeah, once you have your IP address and you go to that in your favorite browser / guacamole, then use the username solo and the password workshop1 and then the # and log in. You should be taken to a VM with a background of the Solo, the desktop has a Solo logo on it. And then from here, you can open up Google Chrome. So double click on Chrome, which is on the desktop. Yep, all right. And then it should automatically open up to the workshops repo, which we will be using. Go into the Gloo mesh folder. And you should start to see the instructions for Gloo mesh. The second thing you'll want to do is open up the terminal. And double clicking, open the terminal. And maybe open them up side by side. Everyone, anyone having issues with that at all? So you should see that we are going to end up with a full machine in the web browser with terminal access. So I do CD and take a look at the folder that I have open here, and then you can do the same thing. But if you go into CD workshops and then CD Gloo Mesh, we now have the workshop material pre-installed or pre-cloned, and then the workshop instructions on the web browser preloaded. Right, and so looking at the overview of the lab environment, it should look similar to what I showed in the slides. And then your job then is to go into lab 1, and let's do the lab 1 and lab 2. I think lab 2. Let's see. Here, let me find something.
Could you please show again how you got there?
Yes. So when you log in to your machine, you should see something like this. You should see a desktop.
Yep.
And what you need to do is double click on Chrome. That will open up the workshops repo, and then click on Gloo Mesh. That'll take you to the instructions for the Gloo Mesh workshop. And then from there, double click on the terminal, and the terminal should open up. And let's just go here, and then go to cd/home/solo/workshops/Gloo Mesh. Oh, Chrome might ask you some questions, but and then Gloo Mesh. Right. So now we should be in the starting position to be able to do the labs. Starting with lab 1. Lab 1. Let's all do lab 1. Lab 1. All it's going to do is we're going to set up 3 Kubernetes clusters using kind. You all should have access to the spreadsheet, so you should be able to look that up if you need access to your machine here. But here, and I'll do it along with you all. And if anybody has questions, please throw questions into the chat or jump on live and ask your question.
Yes,
now,
I just want to mention something.
Go ahead.
Yeah, I want to add something. So you see that actually we have a plugin to allow you to copy code easily. I think you should refresh the page if you don't have the icon on the right side up.
Oh, good point. That will save people. Let's refresh. Yeah, okay, good. Thank you, Adam. Yeah, if you refresh, the plugin should kick in, and you should be able to just click on copy, and then come over here, and then click on paste. Oh. There you go. Restart the terminal. And then paste. So it should just open up the GitHub repo in the browser automatically, but if not, somebody, thank you, Carlos, for adding that link into the chat. But it should just open up, the browser should just open up correctly to the right repo if on Chrome. So we'll give that a second to run. All it's doing is setting up the kind clusters. So you can look in that script later if you like, but it sets up kind, it sets up Calico, it sets up Metal LB, so that we can have real feeling clusters, I guess. Clusters that feel like they would be real clusters deployed in a cloud. Oh, and it looks like some people might be stepping on each other from your addresses. So make sure that we're all on the individual addresses that that we've picked from the spreadsheet. If you could please just double check. Somebody saying they don't have the workshops directory. Alexi, can you tell me either DM me on the chat or yeah, just send me your IP address and I'll take a look at why you don't have the workshops directory. Sometimes the Ansible scripts can be a little flaky, maybe, but it should be there. But Alexia, you asked in the chat. Go ahead and just DM me on the chat. There we go. Oh, okay, perfect. Let's take a look. So this will be Alexi. I'm logging into your machine right now. While everybody sets up their Kubernetes clusters. Yeah. So let's take a look. What do you have?
I just want to mention that I added 6 new, Christian, I added 6 new machines. So if you feel free to like take another one completely if you want.
Okay. Alexi, so in your, if you can see my screen, I am on your machine.
Yeah.
You are in, I believe, the root folder here. You need to go into /home/solo, and then you should see the workshops.
Yeah, it's there.
Okay, I'll log out.
Yep.
You take over it. All right, and so like I'm setting up the last cluster for myself here. And then you can run the check, or you can just go ahead and do kubectl get pods on a particular cluster. The part that you will want to double check is this part, to make sure that when you do kubectl get context. So if I come to the kubectl config get context, we want to make sure that, oh yeah, let's double check that. Let's make sure that we are on the that our kubectl is pointing to the right cluster. So this is in a, make sure you get that last step, this piece. And so if we get context now, kubectl, even though we have 3 clusters, kubectl should be pointing to the management plane cluster. Now there's nothing on these clusters right now, just plain Kubernetes. But like I said, there's Calico installed and there's Metal LB should be installed. But by the time you get to, connection to server was refused from Randall. That is a good question. Kind should not have been one of the names of the clusters that we set up. And so when you created your cluster, did you run the deploy script? Is that how you created it? So this is how we want to create the clusters, not using kind directly. Maybe double check that, or ping me directly, Randall, or ping Adam directly, and we can dig into exactly what's happening on your machine. Okay, so then at this point, if you are able to bring up those 3 clusters and verify that you are pointing to the management plane cluster. Then what we want to do is we want to install Gloo Mesh, the management plane piece, onto our machine here, and then eventually into our management plane cluster. Okay. So let's go ahead and copy paste that. Then you should see meshctl, which is the Gloo Mesh Management Plane CLI, has been installed. And from there, what we want to do is register the two other Kubernetes clusters with the management plane. And in the next lab, we'll install Istio. Now, the steps of registering a cluster and whether Istio is there or not at the time, the ordering there does not matter. If you have Istio there already and then register the cluster, it works out fine. In this lab, the order just happens to be, we're going to register the cluster and then install Istio. But just keep that in mind. What we're going to do to install is so we ran the install script to get meshctl, but we're going to now install the Gloo Mesh controllers into the management plane. So let's run. You see that there's an environment variable here, the Gloo Mesh license key. That should already be on your machine. So just copy and paste exactly as it is. And if that's the case, Q get pod in Gloo Mesh. We should start to see the controllers that make up the Gloo Mesh management plane start to come up. We'll give that a few seconds. We'll give that a second. Okay, looks like everything is running there. And then what we're going to do is, I said, register cluster 1 and cluster 2 with the management plane. We're going to tell the management plane, hey, this is a cluster that you need to be aware of and discover resources on. So let's do the same thing for cluster 2. Now, if I do kubectl get Kubernetes cluster, we should see that they have been registered with the management plane. Wait a sec to see whether people are successful with that so far. Please post questions in the chat if you have any issues with that. So far, all we've done is just set up the clusters, and we've installed Gloo Mesh management plane into the management cluster. In lab 3, what we're going to do is we're going to install Istio. We're going to install Istio. This is based on 1.8.2 into clusters 1 and clusters 2. So let's go ahead and do that. We're going to use the Istio operator to do the installation itself. So let's just copy this and paste it in here. And we'll give that a second to come up. Now, as far as the installation of the Istio operator and the Istio operator config file that we see here, the details of it are for setting up the multi-cluster Istio, setting up the trust domain, setting up the networks, and we're enabling some of the new features of Istio, like the DNS sidecar and so on. But I would say let's come back to this. If somebody has questions about Istio, installing Istio, some of these configs, then let's ask them either on the chat or later. But just follow those instructions there. And if things work out well enough, then Istio system, cluster 1. So if we ask Kubernetes what pods are running on cluster 1 in the Istio system namespace, we should see the Istio control plane is up and running in cluster 1. And so now we want to do the same thing with cluster 2. Take advantage of the handy copy and paste. Give that a second. And if we watch that, we should see the Istio coming up on cluster 2. All right, so now we have 2 different clusters, 2 different installations of Istio. So they're separate, and this is on purpose. Let me give you a couple minutes to catch up to this right here, and then I'm going to go into some of the detail about why we might set up Istio across multiple clusters like this versus alternatives. So why don't you take a couple minutes, get up to this point. You should have Istio installed on cluster 1 and cluster 2, and you should have the Gloo Mesh management plane installed on the management cluster. Ask any questions in the chat, please. I see no questions, so I assume people are moving along, which is good. I'll give one more, I'm at about 30 more seconds. And then we'll go, I'll explain a little bit about Istio multi-cluster. So at the moment, what we have is something that looks almost like this. In Lab 4, we deploy the book info apps. We'll do that in a second. But we have something that kind of looks like this. 2 different clusters, a management plane cluster, Istio control planes running in separate clusters. Now there's a couple different ways to run Istio across multiple clusters. Let me see if I have that slide. One approach is to do something like this, where we have a single control plane that is managing the sidecars for, or the proxies, the data planes for more than one cluster. Right, so that's one approach. And some of the drawbacks to this approach is, well, what happens if that cluster goes down? Then you lose the control plane for potentially more than just one cluster. All right, so that's one big drawback. Another approach is, okay, well, why don't we deploy the control plane per boundary, per configuration boundary, right? So if a cluster goes down, it takes down that control plane, but it doesn't take down everything. And so this has better isolation characteristics, but it adds more configuration overhead. But with Gloo Mesh, we suggest this approach where you try to minimize the impact of one of these control planes going down by splitting them out into their own clusters. And then with the configuration overhead, that's where the management plane comes in and automates a lot of that stuff away. So you get the best of both worlds, where you get the safety and isolation of being more highly available and fault tolerant, but reduce the overhead of operating these things. So that's the scenario that we have set up so far. Go ahead and do lab 4, which installs the applications into the 2 clusters. So let's take a look at installing parts of the book info demo onto cluster 1. So kubectl get pod in the default namespace on cluster 1. We see that those are coming up. And then on cluster 2, we will deploy the book info demo, but it'll be slightly different. We'll take a look at how that's different. We're deploying product page, details, reviews. These are all, if you're familiar with Istio and some of the out-of-the-box demos there. Let's see. Right, so in cluster 1, we see we have product page, details, and then reviews service. We have 2 different versions of the review service. In cluster 2, so that's running in cluster 1. In cluster 2, we have 3 different versions of the reviews service. So this scenario illustrates a couple of different things. One being you might have different clusters and they're probably heterogeneous or not exact replicas of each other. The second being, even if they were replicas of each other, if you introduce changes to your applications, you would like to do that in an extremely controlled way. You might introduce those changes to just one cluster first, but you might want to influence the traffic routing so that some percentage of traffic ends up on this cluster where you're canarying a new version of an app. And we will take a look at that scenario in more detail. But at the moment, what we have is 2 different clusters running Istio. The workloads running on those clusters are not exactly the same, although there are some shared pieces. And the management plane right now has been configured to kind of oversee and watch both of these clusters, which we haven't gotten to yet, but we will in a second see what it is that the management plane has discovered. So if you go ahead and do some, let's see, I think, do we do any port forwarding or no, let's just open this directly. Click on that link from the lab, you should be able to go to the product page app directly. So now if you refresh a couple times, you should see the traffic's going to bounce back and forth between no stars and black stars. Which is expected. So that's reviews V1 and reviews V3. Reviews V1 and reviews V2. Reviews V3 is red stars, but we don't see that. We don't see that yet. All right, how are people doing over here? Thank you, Adam, for covering the questions here. So now, if folks have followed along successfully, then you should be at lab 5. And in lab 5, we're going to actually make use of the management plane. So if we come over here, let's go to the terminal real quick. Let's go off script just a second. If we do kubectl get meshes and dash capital A. Now remember, kubectl is pointing to the management plane. If we do get meshes, we see that the management plane, since it was already registered to those two clusters, automatically discovered that there's Istio running in cluster 1 and cluster 2. If I do, instead of get meshes, let's get workloads. I think that's the right one. We should see the management plane has discovered workloads that are running across both of these clusters. So in a way, the management plane, well, its discovery capabilities are able to discover where the meshes are running and what's running where, and keep a catalog, a dynamic and changing catalog about what services are deployed where. And you'll see in a second why this becomes extremely valuable. So in lab 5, the scenario that we've set up is we've got 2 different Istio control planes running across 2 different clusters. Let's extend this out and think, this could be 10, this could be 100, but we're doing 2 just to keep it simple for the lab. And the first thing we'll notice is that these Ist clusters they have a different root of trust and they have different trust domains. So the workloads that are running in cluster 1 out of the box are not going to be able to talk to or trust the workloads that are running in cluster 2. So let's take a look at 2 different things in lab 5. One is going to be, well, what if we created an abstraction that treated these 2 different clusters or n number of clusters and meshes as though they're a single logical mesh? All right, that's one concept that we're going to look at in lab 5. The second is if we treat all of these things as though they're just one mesh, then we might want to route traffic between services that run in the different meshes. So what we need to do is unify those different trust boundaries. And Gloo Mesh, the automation management plane, will take all the necessary steps needed to unify those trust domains. All right, so let us let's go ahead and let's start walking through lab number 5. And at the end of lab number 5, we'll take a break. Maybe we'll do 10 minutes or so. And so let's go for a little bit here, and then I'll announce the break and when we're returning and so on. But let's start going through lab number 5. I'll give you a second to do it on my screen too, if you follow along. But if you want to actually do it on, follow the instructions on your machine. How are we doing on the chat? Seems okay. like I said, walk through lab 5. I'll explain a little bit about what's going on. Let's enable mutual TLS on both clusters. So what we're seeing in lab 5 is that, first of all, we enabled mutual TLS. And the second thing is the roots of trust in the two different clusters are different, like I said, as we expect, because they were set up as separate control planes. So if we look at the root in cluster 1, it looks like it's V plus VM equals sign. If we do the same thing in cluster 2, plus VM equals sign should be different. We see something completely different as the root certificates. So what we're doing is creating this virtual mesh. And in this virtual mesh, we're specifying a few different things. First being which meshes are part of this virtual mesh that we're going to create. What should the root identity or sorry, the root CA, where that should come from. And in this case, we are just generating one, but we can plug this into backend PKI. And then we have our federation config right now, which is just open to everything. That means every service can talk to every other service. But we can tailor that as well. So let's create this virtual mesh. And what this is going to do is, under the covers, behind the scene, is going to do that automation that the management plane is built to do, which is basically go out and configure the individual clusters, or rather the individual control planes of each of the meshes to appear as though they're part of one single mesh. So that'll do things like unifying the trust domains. That'll do things like installing the service entries on the right clusters. It will be installing the right destination rules on each of the clusters, so we know when there are things like subsets or different versions of services that exist on remote clusters and so on. So this, although it was one simple command, this setting up this virtual mesh, a lot of the configuration toil that you would otherwise have to put into place and consistently maintain and keep up is being done for you. So now if you run through the rest of lab 5 here, what we'll end up seeing is the trust domains have been unified. So you can run through some of these steps. It'll step you through the actual pieces of the different clusters where the CA certs are stored, and then have you recall the services. Everything's using mutual TLS already, and we should see that the base CA, public CA, is the same across both of those clusters. And that will set up our ability to then treat the two different distinct control planes and meshes as though they were one. And we can start writing access policies and traffic policies and so on against this virtual mesh, and have this multi-cluster system behave consistently as though it was just one. But of course, like I mentioned previously, it's made up of multiple individual pieces. So if one cluster ends up going down, it doesn't take everything else down. So we have the uniformity and consistency of operations with the high availability and isolation of the deployment architecture. I'll give you a few minutes to go through and finish up lab 5. And then after those 2 minutes, 2 or 3 minutes or so, now we're gonna start to take advantage of this automation in place, this abstraction that's in place, and start doing things like limiting access to services, calling each other in and across the meshes. We'll do things like controlling the traffic for things like canary rollouts and releases. And I think later on, we'll also get to how do we visualize all this stuff that's running. We'll take a look at the UI. We'll take a look at how do we extend the data plane using something like WebAssembly and do this across multiple clusters. So once you're able to get the foundational pieces in place, it opens up a lot of valuable operational control and oversight of the system here. So I'll finish up lab 5 in the next minute or so. Then after that, let's take a 10-minute break. So it'll soon be 10 minutes past the hour. Let's come back here at 20 minutes past the hour. All right, and in the meantime, we're here to answer questions and help you. So please ask in the chat or jump on the microphone and ask over the microphone, and we'll be here to help you. But otherwise, take a break, and we'll all be back here in about 10 minutes or so.
Hey everyone, just a quick question. Who is still in the first labs and need help to reach to lab 5, for example?
All right, we're going to get started in about a minute. All right, let's get going. Tommy, I see you're still having some errors possibly here. Looks like after you set mutual TLS to strict, and after you've created the virtual mesh, that you're getting some errors here. Tommy, can you put your IP address in there just real quick? I'll take 1 second and we'll try to just do it live real quick. All right. All right, I think this is Tommy's computer. Let me just. All right, let's see what we got. I think I'm on the right machine here, right? So, oh, no, I'm not. I'm on somebody else's machine here. All right, so let me see here real quick, Tom. I think I have control of your system here. Good. Good. That looks okay. What about? Sir, that looks fine. All right, so then if we do something like that, I see the certs. Oh, you're saying that the the certificates are not verified. Yeah, that's probably true because we use the root we're using is created by ourselves, and the CA bundle is not. Let me see. Let me see. What does it look like on mine? Okay, so I am seeing that on mine as well. You do get the root CAs back, so you should be able to continue on with the lab. Now, about the verification, let me think. So the root CAs we create, they're not signed by any authority, any real authority. And it just depends on where's OpenSSL thinking that the trusted bundle of CAs exists. So I think when Envoy creates a connection, a mutual TLS connection from one pod to the other, those certificates will be validated and verified. But since we're OpenSSL making this connection, OpenSSL doesn't know where the trust bundles are that correspond with our CA. So it probably doesn't trust, but that's okay for this particular lab. Yep, no problem. So let's go on to lab 6. So we have our 2 clusters. We have Gloo mesh set up. The automation is in place now that we can start to use the abstraction that's in place. The abstraction that's in place is, let's worry about configuring traffic for service A and service B. And this might be deployed on 1 mesh or 10 meshes. Let's not be caught up in what the number of clusters are and which service is deployed where and which version is deployed where and all that stuff. Let's just focus on the rules, either access policies or traffic policies between service A and B. So let's look at lab 6, and I'll scroll down there, and let's look at enabling the RBAC capabilities, or the access policy capabilities in Gloo mesh. So we're going to do that by enabling the global access policy feature. So let's go ahead and enable that. And we could have started off with this. Go ahead and paste that. And now if you go to your Bookinfo app, we'll give it a second. Oh, we should see it. Happened a little quicker than I expected, but we should see that the global access policies are now enforced. Everything is denied by default. So you have to whitelist, you have to be very explicit about what traffic is allowed. All right, and so what we're going to do is we're going to use an access policy. So this is one of the APIs exposed by the management plane. And this API is built as a declarative resource. So do you declare the intent of what you want the outcome to be, just like you do in Kubernetes, right? You declare your intentions for what the infrastructure should do, and then Gloo mesh will go and automate this. So access policy is one of our APIs implemented as custom resources in Kubernetes. So if we copy this access policy, which basically allows traffic to come in from the Istio ingress gateway to the product page. So that's what this access policy is doing. You can see that there is awareness of multiple clusters. And in this case, we're saying in cluster 1. But the beauty about this API is that although we can be very fine-grained about where this policy should apply, we can also do it agnostically of the clusters. We can just say, any time we have an ingress gateway account that wants to talk to a product page service, allow it on any cluster, right? In this case, we'll be fine-grained about specifying where the policy should be enforced on cluster 1. So now if I come back here and refresh, and it takes a second for it to come back, but now we see the traffic from the edge into the product page service works, but not the other pieces, not from product page to the other services. So let's go ahead. I'll let you all run with lab 6 here. And in Lab 6, what we're focused on is using the Access Policy API, which gives you a selector model for both the source and the destinations for defining what groups of services are allowed to talk with which other groups of services. And that may be across multiple clusters and might be in a single cluster. And that might apply to more than one service account or workload, but you have the flexibility to treat the access policies in terms of which services are communicating with each other, which is a slightly different shape of API than what you have with Istio. So let's go ahead and create that. Little by little, we should be enabling the traffic to come back. We see now the reviews, but details, oh, and details, so yeah. We enabled it to both there. But ratings, we still don't have policy for, so let's create that. There we go. Now we've slowly enabled all of the traffic to come back, explicitly in this case. And then moving on to Lab 7, what we're going to see is we're going to take some of those same ideas that we saw in Lab 6, where we're using selectors and labels to define either access policies. In this case, we're going to look at using that same model for defining traffic policies. So in Lab 7, here, let me see. Let me give you a minute or two to finish up Lab 6, and then we'll dive right into Lab 7. Okay. Now in Lab 7, what we're going to do is we're going to use a different API called a traffic policy to control the flow of traffic in scenarios that cross multiple clusters. So as we saw earlier that we had some components of the Istio book info demo are deployed onto cluster 1, and then some components of the book info demo are deployed on cluster 2. But specifically, the reviews v3 part of the application is deployed on cluster 2, but not on cluster 1. So if we do kubectl get pod on cluster 1, we can see reviews v1 and v2 are deployed. If we look on cluster 2, we see reviews v1, 2, and 3 are deployed. In our bookstore app, book info app, if we refresh, we're seeing the traffic bounce between v1 and v2. But let's say we have introduced a canary release of reviews in our canary cluster. That would be cluster 2 in this case. And what we want to do is we do want to direct some traffic over to this canary release. And in this particular demo, we're going to actually route 75% of the traffic over to cluster 2. It's not typical in a canary release, but I guess just to speed the effect of the lab along. So let's create the traffic policy. Again, we're creating these policies, access policies, traffic policies on the management plane cluster. And then the management plane is interpreting these, translating that into Istio resources, orchestrating that across the various clusters and service mesh control planes. Let's go ahead and create that. And in a second, or in one of the future labs here that we'll see, we'll actually dig into the Istio resource and everything that was created. So now if I come back here and I refresh, cross fingers as well. Oh, no red stars. No red stars. We were expecting red stars, but I think the problem here was an expected one. Because what we see is that our access policy is working. We don't allow the traffic to go from cluster 1 to cluster 2 yet. So let's open up that path with using an access policy that will allow traffic to the ratings service, regardless of what cluster it's on. So now we've created that access policy. If we refresh a couple times, let it kick in, now we see the traffic is flowing. So from a security standpoint, we can treat the configuration of the system much more consistently by using this abstraction here, this virtual mesh abstraction, to secure the traffic or allow the traffic. And we can control the traffic, whether or not traffic should or should not be going across the different clusters, maybe for a release rollout, like we see here. So now in the lab, we'll go into some detail about all of the resources that were created. Like I said, the management plane is an automation engine. It saves you from having to manually create these configuration objects, and it orchestrates them across the various clusters, and therefore reduces the amount of human error that can be introduced when shuffling around large volumes of configurations, and adhering, I would say, to the principles that we kind of had at the onset, that Istio's config is intended to be lower level and controlled by something a little bit higher level. The Gloo mesh management plane is that higher level piece. Okay. Now in lab 8, we're actually going to skip it. Traffic policy and traffic failover are important topics, but we're going to skip this lab for 2 reasons. Number 1 reason, the functionality that we use under the covers to implement traffic failover is actually broken in Istio 1.8, unfortunately, down in the Envoy proxy. The second reason is in Gloo Mesh, one of the more recent releases, we actually have a different implementation for failover and locality aware load balancing that we're going to end up doing. So we need to just kind of remove this lab altogether and replace it with the newer instructions. So that functionality does exist. It's just not been updated into the lab just yet. Oh, I see a question. I don't see destination on the default namespace would be 3. Let's see. So there's a question about some of the resources that have been created. Destination rule.
Yeah, so my question is, so in this screenshot,
Uh-huh.
within the destination rule, there are 3 versions of reviews defined, right? V1, V2, and V3 in a single
Yeah.
object, of destination rule. But in reality, what I'm seeing is there are 2 destination rule objects created, one in the default namespace, the other one is in is still system namespace. And V3 subset is only contained in the destination rule belonging to the still system namespace. So there's some drift here between the documentation and the reality. I just want to know maybe there's some design change behind that. I just want to know more detail about it.
That must be the docs might be a little bit outdated. Let me see. So we have the which one is this for? Reviews. Yeah, I see reviews here, and then I see reviews in the Istio system is for a different host, though. I see. Okay, so I'm looking at cluster 1, right? And so basically the question is the destination rules either in the docs might be outdated, or there's at least 2 reviews destination rules. What are they for? And the reason that we see that, so if we take a look at the destination rule for the review service in the default namespace, let's see, copy. It's in default, right? Oh, and paste. Oh, no, that's wrong. All right. So we have the destination rule for reviews in the default namespace, and that sees the 2 different subsets, version 1 and version 2. The one that we see in the Istio system namespace, let's try to get them all again. That one is called reviews. Reviews default cluster 2. And the reason why they're different is because this is sort of playing the role of service discovery. Right, so this is the one that's in Istio system namespace. Maybe that's what this image is showing. No, maybe not. Maybe the images are slightly out of date. But the point is that there's the destination rule that's associated with the reviews running in cluster 1, and then there's the destination rules that are associated with the reviews running in cluster 2, which have different subsets, and we might be able to route to those subsets. And so that's the reviews destination rule in the Istio system namespace reflects those that are running in different clusters. Does that make sense?
Yes. Maybe can you talk a little bit more regarding the workload CRD, the service entry, how does those get populated?
Yeah. So if we take a look at, so let's first define, right? So the kubectl, let's look in context cluster 1. Let's get the service entries across the entire cluster. So now a service entry in Istio basically is an entry into the Istio registry for that control plane. In this case, in cluster 1. And the service entry, what it basically says is this service might not run in this cluster. It runs somewhere else, but I want it to be part of the mesh. All right, so we create a service entry for that. Now, in this case, what we're doing is we are creating service entries for services that live in cluster 2. Right? Because like I said, the virtual mesh will configure Istio and do all of these things to make it look like all of these services are part of one single mesh. This is one of those pieces. So Gloo Mesh is going to say, oh, I know what services are running on cluster 2 or cluster 3 or cluster 10 or whatever. And I also know that cluster 1 has services that need to access those that live on these other clusters. So for cluster 1, I am going to tell cluster 1 about all of these other services that live somewhere else, so that the mesh in cluster 1 will know about them and know that it can route to those. And so that's why the service entries get created. Does that make sense?
Yes, but I guess one look into is there a way to control the visibility of that thing? Like, does the cluster 1 gonna see everything from the cluster 2, or is there any control knob we can use to say only this part of service from certain namespace got to export it to the other cluster?
Yes, good question. So right now, when we created the virtual mesh, there was a federation config piece there, and we left it open, which basically means federate everything to everything, which isn't, is fine in a demo and fine for explaining, but in reality, we need to fine tune that. So we can be very granular about what services get exposed across the different clusters. We can do that by defining, by either looking at access policy rules, like what services are allowed to talk with which other ones. We can do that by additional metadata about defining what services talk with which other services, and then automatically going and creating those service entries. So we can be very fine-grained and scope down what service discovery is available and enabled on the various clusters. But to your question about what is the service entry and how does that fit, it is part of allowing the services to communicate with each other across multiple clusters. And so if workloads come and go, Gloo Mesh is constantly reconciling this. So it's not something that you have to create yourself or maintain or check on or anything like that. If ingress gateways change, all of the details of the service entries are updated automatically. Okay, good question. So again, we're going to skip lab 8. Hopefully, during that explanation of service entries and so on, allowed folks to catch up. And then if we look in lab 9, lab 9 goes into a particularly important piece of the puzzle here, which is that role-based API that I was talking about earlier. That there are different personas, different groups within your organization that might want to take advantage of the features of the mesh, the capabilities of the mesh. And you might want to say for the service owners, they can use the Gloo Mesh API, but only to configure traffic routing for their service. Or maybe you have another group that is trying to call a service and you want to give them access to configure their service as well as calling another service, but not everything else. Right, and as we saw earlier in the slides, in Istio, you use a virtual service for this. But if everybody's trying to work and try to configure the virtual service, then that becomes very problematic. So let's dig into lab 9, and we're going to take a quick look at what that role-based access policy, or what that RBAC looks like. It leverages some pieces of Kubernetes RBAC, but then adds additional RBAC policies on top of that. And we can explain that in a second why that is. But start to go through lab 9, and for any of those folks who are having questions, please ask them on the chat, or just jump in and ask them. But I'll give you a second to run through lab 9. Lab 9. And then the last 2 labs after lab 9, we're going to look at WebAssembly, and then we're going to look at the UI for managing all of this from a UI. So I'll give you, let's say, 5 minutes. Go ahead and do lab 9. Ask questions, and then I'll see you at lab 10. Okay, let's get back to it. Let me see. So since we skipped lab 8. Yes. Yes. All right. Thank you for that. Yeah, we got that. So we got to remove that. Yeah, we got to actually remove the traffic policy before we start writing rules about who can write traffic policies. So thank you for that. All right. Now we're down to the last couple labs here. In lab 9, we explored, how we can lock down different functionality in the API, and specifically lock certain roles down to services that they own, which might live on multiple clusters. That's a big part of why we need to have our own RBAC system, because Kubernetes doesn't allow you to write RBAC down to the specific field of a resource. And when we're considering multiple clusters, we absolutely need to have that capability. The service is going to be deployed in more than one spot. Now, the next pieces of the lab, so looking at lab 10 is about extending the capabilities of the data plane. So as requests are flowing through, you want to make changes to how things are handled from a security standpoint, maybe changing the shape of messages by doing transformations, enriching with additional headers and so on. We can use WebAssembly to inject that behavior into the different pieces of the data plane. Now, before we move on to the next lab, I do want to point out 2 things. One, I'm going to paste a link into the chat. It should be open. It's a Google form. It should be open to everybody. If you could please, at some point, take 2 minutes to fill in the feedback. Give us feedback on the content and the delivery of this workshop, so we know whether or not it is valuable or useful for people, and we can continue doing them. That's the first thing. The second thing is this. So if we go to solo, and let's go to events real quick. Events. So that this workshop is here. And then at the end of the month, like I said, we're doing SoloCon, and we'll have a bunch of announcements and go into more detail about this type of stuff. But I also wanted to point out that next week, Tuesday, we are doing a workshop focused completely on operating Istio. And this is more of a Istio day 2. What are the challenges of operating Istio, understanding how it works, understanding the sort of things that put you in a better spot for doing upgrades and operating Istio in day 2, things that are not necessarily in the docs, things that we've learned the hard way by working with our customers supporting Istio in production, small deployments, large deployments, everything in between. And going into some real nitty-gritty details about Istio. So if you're interested to learn and go into a little bit more about operating Istio, this is going to be a series of workshops. This is part 1, understanding Istio. The second part will go into more advanced things like operating Istio within a GitOps workflows, setting Istio up to be extremely secure with tying into PKI like Vault and Amazon certificate management and this types of things, doing upgrades in a very safe way, upgrading from older versions to newer ones and so on, potentially even doing skip upgrades. So again, this is a series on operating Istio in day 2, and we're leading the first one next week on Tuesday. So go ahead, please fill out the survey. check out the future coming workshops if that's desirable for you. Now back to the labs, and what we're going to do is we're going to go to lab 11 first. We're going to go to lab 11. We're going to get through kind of what are some of the visualizations and tools around what we've already deployed, and then we're going to look at how we extend that with WebAssembly. So let's go ahead and port forward the UI in lab 11. And then we're going to open this in a new tab. And what we see here is a read-only web UI that describes the components that are in the mesh and in the various clusters that are under management with Gloo Mesh. So we can see we have 2 clusters that we've discovered, the various workloads that are running in the clusters. We see 1 mesh is currently configured, but if we click on View Meshes, that's because we're treating the virtual mesh as one single mesh. Inside the virtual mesh, we see the constituent clusters and the constituent service meshes that make up that mesh. If I want to see the virtual mesh details, we can see things like the traffic targets and workloads that we've created, the various failover. Oh, we didn't do the failover lab. The various policies that we've written, either access policy or traffic shifting policies. If I click on one of the policies, we can see what does that apply to. In this case, it looks like 75% of the traffic is going to version 3 of the review service, like we saw earlier. And this is, like I said, a read-only UI. Part of the reason why it's read-only is because everything that we do in Gloo Mesh is based on declarative custom resources. And we want to be able to visualize it and see, but we want to have the single writer, I guess, be either your operations team or more likely a Git flow or GitOps workflow that deploys the custom resources into the clusters. And then you should be able to visualize them. Now, around things like observability, multi-cluster observability, what I can say at the moment is stay tuned, because at SoloCon we'll have some interesting announcements that you might like. But even at the level of clicking into each of the individual meshes, so if I click on the debug tab here, we can go into each of the meshes and see what are all of the resources, the Istio resources that have been configured. So in terms of the virtual services or destination rules that we were looking at earlier, the service entries that were created, any of the auth policies, these are this is a way to be able to quickly get through and look at, all right, what is happening on the individual meshes, and specifically what's going on with the Istio configs. All right, so now if I click on the WASM tab, the WebAssembly tab, we don't have any WebAssembly filters deployed here. So let's come back to, now we'll go from lab 11 back to lab 10. And what we're going to do is, let's see, I think this lab walks us through actually from the very beginning, creating a WebAssembly module. That might exceed the time that we have left. Let me just quickly come back to the slides and see whether there are any slides. So I think this is what we're going to do for lab 10. We're going to, let me just give you a little quick intro to the Envoy, extending Envoy, and why this might be useful. And then what I'm going to do is I'll leave the lab environment up for another day or so, and you can, if you want to dig into the WebAssembly pieces, then go for it. I do want to leave time, maybe about the last 15-20 minutes here, for questions in general about what we've covered, about Istio, about multi-cluster Istio, and so on. I want to open it up to everyone. But just real quick, leading into Lab 10, Envoy proxy is the data plane in Istio. So a lot of the features and functionality that are exposed by Istio and by extension the Gloo Mesh Management Plane are basically built around Envoy proxy. And Envoy can do extremely powerful things. One thing that we've noticed very consistently is that when we deploy Envoy proxy either at the edge as a gateway using something like Gloo Edge, or as a mesh with Gloo Mesh or Istio, there's always a need to extend the capabilities of Envoy to play nicer or be more backward compatible with the existing apps that an organization might have, or assumptions that an organization might have. That might be things like security. Maybe they handle message signatures differently. They do HMAC stuff. Maybe they handle JOT tokens different. Maybe the token isn't really JOT, it's some other custom thing that they've had for a long time. And for the applications to actually communicate and participate with their existing deployment and existing services, they need to be able to fit in with some of these assumptions. So extending Envoy is a C++ application. When you want to, and it's built in a very modular way, an extensible way. So you can extend Envoy by writing C++ filters, which we've done at Solo for quite a few of our customers. But doing that means that you're layering on top of Envoy, and you're no longer using the stock Envoy proxy. Right now you've built your own, because you have to statically link those extensions into Envoy itself. Now that is a way to, Envoy is awesome. Being able to extend it is extremely powerful, but there's also a high barrier there. Envoy is written in C++. Not everybody can write C++. Envoy has a build system called Bazel, which is kind of a pain in the ass. And then I guess the part that most people care about is that if group 1 has a feature they want to put into Envoy and they want to use, and so does group 2 and 3 and 4 and so on, you start to build this Frankenstein of a proxy that now everybody has to use to get everyone's feature, when you might only care about one little piece of it. And that's not ideal. The proxy becomes bloated. And that's where WebAssembly comes into the picture. WebAssembly originated in the browsers exactly to extend the capability of applications running in the browser and give you more options than just one language to write in. So in the browsers, that would be JavaScript, right? So you can write your applications in something other than JavaScript, compile it into WebAssembly, and then actually run that binary in the browser in a safe sandbox manner. Now, if you look at the same model, what we're doing is we're extending the capability of Envoy in a safe sandbox by dynamically injecting a binary that's code that you can write in C++ if you want, but Rust-Lang, Rust, TinyGo, AssemblyScript, and a host of others that are coming. So it gives you more options for how to write these extensions, and still gives you the power to dynamically load them into a stock Envoy. Right? You just take Envoy off the shelf, inject the capabilities that you need for your particular workload. So a different team, a different group, some other clusters can customize Envoy however they want it, and then it can run in the data path. Now, this is all good, but how do you actually get started building some of these projects? There are some assumptions about how a WebAssembly filter would run in Envoy. How do you actually build it and package it and distribute it? And how do you pull it down and install it and manage it, especially across multiple clusters? So as you can imagine, that is where Gloo Mesh's WebAssembly capabilities come into the picture. So in Lab 10, we'll walk you through actually bootstrapping from the very beginning a WebAssembly project, how you build it, how you package it, how you push it to a registry, how you pull it down, and then deploy it into your mesh, into Istio. So that'll be Lab 10. Like I said, the steps to actually doing that are going to exceed our time boundaries that we have for today. And I do want to leave time for questions. So I'm going to leave the lab environment up for probably the rest of today, maybe tomorrow. So if WebAssembly is interesting to you and extending a service mesh is interesting, then go ahead and take a look at Lab 10. Now I'm going to come back here. I'm going to put our contact information back up here. And I will open it up for questions live. And as well as I said, leave our contact information here. You can reach out to us afterward as well. But we have about 10 minutes, 15 minutes left. I just want to see, oh, yes, please fill out the feedback form if you could. This gives us a good indication of what the things we need to tweak and change. Some of you are already given some feedback in the chat, which is awesome. Please fill out the form if you could just take a minute or so. But yeah, with that, thank you all. But we're still here for another 15 or so if you want to ask questions.
Yeah, just want to add something super quick. You guys will receive also an email in a few days, and you can request the recording of this workshop.
That's right. So people are interested in Istio, or people are running Istio. People are thinking about going and deploying Istio across multiple clusters, from entry-level questions to, try to stump us questions. Everything's open. Please feel free to ask. I see Carlos has a question. Okay, I see. What is the command that you ran for that output? Oh, right. And did you enable mutual TLS, strict mutual TLS, which was one of the steps? Oh, very good. like I said, I'll leave the lab environment up for a little bit, and it's worth it's worth spending some time going in, breaking if things aren't working, blowing away the clusters, resetting them, bringing them back up, going through some of the material, digging through how things work. Definitely we'll leave the lab up for a little bit. Anybody else? Was it a worthwhile lab? Okay, here's a question. Can you give any feedback about Istio and Open Service Mesh? OSM implements SMI, but both Istio and OSM are built on Envoy, I believe. Yeah, that's a good question. So Open Service Mesh is built on Envoy proxy. OSM was announced, I believe, back in the summer of 2020. And so I guess the question is, what is the difference or feedback about the difference? So let me, instead of talking about OSM specifically, I'll talk a little bit more generally. So Istio uses Envoy proxy, and there are a handful of other service meshes that use Envoy proxy as well, which in my opinion validates pretty strongly that Envoy is the ideal proxy for building out this type of infrastructure. And one thing that I've noticed in working on Istio for 4 years and Envoy in general is that the architecture, getting the architecture of the service mesh in place is almost trivial. And what I mean by that is the control plane, the service meshes will have a control plane, they will have a data plane. Those data planes, those proxies need to be associated with the workload somehow. Right, that part's trivial. Now, actually building a control plane that will scale, actually building the right API and enabling the right pieces of Envoy to successfully operate and allow it to be adopted in a real enterprise organization, in real production workloads. Like all of those use cases, all of those edge cases, the maturity of the control plane, that takes time. And unless you're going to copy another project, it's that, and you're going to go and build it yourself, it's going to take some time. In my estimation, it's about a year and a half, maybe a little bit longer, 2 years, to get a service mesh up to that threshold where you can run it in production. And we've seen, like, so for example, console service mesh from HashiCorp, they came out probably a year and a half, almost 2 years ago. They are now getting into that state where running console as a service mesh is realistic, but it took them some time. I would say that something like Kuma was released maybe a little over a year ago, maybe a little bit longer. They still need a lot more time to bake. And I will say the same thing about Open Service Mesh, that there's still a lot of maturity, a lot of things that, even though I think they're about to 1.0 and all that stuff, when Istio went 1.0, I said, do not use this in production. It's not ready, right? I remember it was July 31st, 1.0 came out, and I said, do not use this. And I'll be perfectly honest, the other ones need some time to bake and go through the same edge case. You got to figure all those things that enterprises need when they run a service mesh. So with all that being said, I will say that Istio is the most mature, is the most advanced, both because of that time and because a lot of people are using it, kicking the tires, putting it through its paces. A lot of people have gotten to the point where they've deployed it and are running it in production. Now, like I said, from my viewpoint, being on the Istio steering committee and helping out with the organization of the IstioCon conference, there was way more talks, use cases, studies, customer studies about operating Istio than we could have put into the conference. Now, just my own anecdotal experience watching this market is gone from people talking about service mesh, talking about things like Istio, demoing it, to putting it into their architectural diagrams, to actually now deploying it and having been in production for a while now, for like the last 6 months, let's say. So it's becoming more actionable. People are actually adopting. So just in general, I would say Envoy is extremely powerful, but building a mesh is not easy. And that Istio has matured significantly, easier to run than it was in the beginning. Let's say the APIs are settling down. The other ones are playing catch up. So hopefully that gives some perspective there. Feel free to challenge any of that or ask more questions.
Yeah, I asked that question because someone in another group in our company said they are only investigating or they want to investigate service meshes that implement SMI. And I'm not sure why, although we are a Microsoft shop, so Microsoft might have pushed it.
Right, and so SMI is interesting. The idea of having an abstraction above the service meshes actually originated with the work that we did with a project called Gloo back in November 2018. And Microsoft came to us February 2019 and said, "Hey, this sounds really good. Why don't we make this a project, community project?" And of course, we were a small startup at that smaller startup at that time. We said, "Oh yeah, Microsoft, yeah, all right, let's do this." And then we started going down the path of SMI, and then we realized what was happening with it was that it was, first of all, it was becoming a lowest common denominator abstraction, which can be good if we can. So this goes back to some of the things that I said, that the rest of the meshes are playing catch up, right? And if we're going to do lowest common denominator, then we got to support whoever's farthest behind. And in this market where the capabilities of Envoy-based proxies, Envoy is there. Envoy is changing, it is, but not as volatile as the APIs around the service mesh. But if you have a set of capability and one mesh implements 90% of it, let's say, I don't know what the actual number, but let's say a large number, percentage of the API, and another one only implements 10% of it, then your SMI, or rather your API is not going to be all that useful. And so so what we've done is we've evolved a little bit past that, and we're saying this is what we think the API of a service mesh should look like. And it should include some of the advanced pieces that Istio now supports, because we don't want to, there's no reason to eliminate or exclude functionality just because 8 out of the 10 service meshes don't support it. So what we were saying is, let's build the abstraction so far that this would be the right abstraction for a service mesh, regardless of what it is. And if the other meshes don't implement it, we'll throw a not implemented yet response. But we want to be able to incorporate those eventually. So what I would say specifically with OSM is that OSM, first of all, has a ways to go. SMI is going to be too limited of a lowest common denominator API to get a lot of the value that Envoy has today, and that may eventually they will get there, but it's still, in my opinion, a bit early for OSM.
Thank you.
Yeah. Have you seen cases? Right. Have you used cases where you've seen Istio be used with console as a service registry across a multi-cluster environment? How does this contrast against using console enterprise with mesh gateway production setting, especially with regard to the messaging. Console enterprise and mesh gateway, I assume, is the console pieces, versus using Istio as using Istio with console as the service registry across multiple cluster environment. So in general, so what I would say, part of the architecture that we looked at today was, how do you architect Istio from a availability standpoint? How do we architect from an isolation standpoint? And some of the operational burden that introduces. One of those things is service discovery, service awareness, and then facilitating the knowledge around those pieces. Now, I have not seen people use console as a service registry for multi-cluster environments. We've seen people kind of kick the tires with console as a registry for services that live outside of Kubernetes, for example. I would say generally, and this is not like a rule, because there's probably way more workloads that run outside of Kubernetes that run inside Kubernetes. But for the people who are adopting Istio, I would say they're, a large portion of them are running in Kubernetes, and so they're not looking at it from a we have console already standpoint, or not trying to put console into Kubernetes. So that's kind of what we're seeing in general. Now that might be self-selecting, because those are the people that we end up working with. But so I haven't seen too many multi-clusters console deployments. So I don't see any more questions coming in. Yep. And then we have about a minute left. So yeah, again, thank you all for coming. You have access to the lab material outside of right now, and reach out to us offline if you have more questions or you want to go into more detail. Please fill out the survey. Look out for some of the workshops we're doing next week, and hopefully see you at SoloCon on March 22nd, March 23rd timeframe. So with that, I'll give you back the rest of your day, and thank you so much for joining.